Okay, thank you, Andrew and James. That was pretty comprehensive work. For anyone who's on the gully spectrum like myself and the previous speakers, it's very interesting, the outcomes of these sorts of research projects, and they certainly contribute to the efforts that we try to put on ground. I'm only talking about large-scale gully interventions here. There are many other sources of sediment, of course, but I wanted to talk particularly about the challenges of putting these sorts of works on ground, I suppose. There is great work on working out where to target these sorts of operations, and in the last few years it's become even more valuable for us to be able to work out how to approach remediation of these sorts of landscapes. That gully is producing about 620 tonnes a year, so when we talk about gully systems that are producing 10,000 tonnes, you can imagine they're quite degraded landscapes. Okay, I guess the main point I wanted to start on was just how we've benefited. So I represent a consultancy that looks at design and implementation of works on ground, and we've got an associated company that does the soil conservation works as well. And they are, at this scale, sort of civil programs. So there's a number of things I'd like to go over that just, I suppose, frame how we can produce large-scale remediation works on ground on rural properties, basically agricultural properties and farming properties. They're certainly not in the business of having large civil works programs on their properties, so it's a very tricky exercise to negotiate getting these things delivered. So essentially the sorts of things that we find have helped us over the last, well, Andrew just described 5 years of research, is that it really has helped with targeting where we're going to work. It's helped also with the design. So some of the stuff that James has just gone over about where the most active areas of gullies are, they're the areas that we choose to target because it's the most cost-effective way to go forward. And just also some of the trials that have been done through various programs, the LDC programs, and also the ones that we've worked on, they help us to modify the treatments and the approaches we take to try to get better outcomes. Andrew noted there that we've been able to achieve at Strathalbyn a 98% effectiveness rate, and I think that's through the dedication of the people that I work with on ground. I'm a spokesperson here today, but there's probably about 50 people who have worked on that project. So from operators right through to businesses that run support and logistics support for us to do these jobs. The methods of assessment of the effectiveness is also really valuable as a feedback loop for us to know that there might be areas of where we're working where we can improve how we deliver these programs and what the effectiveness of those works are. And so we really appreciate the opportunity to collaborate with researchers to be able to get that information to hone in on how we do our jobs. The other thing is the methods of measuring cost effectiveness. Obviously that's a key factor for us. We have to quote jobs which have to be delivered in a cost-effective way. There's an expectation that tonnes of sediment delivered to the reef are sort of abated for a reasonable cost, I suppose. And so we're constantly looking at how to improve those, that cost-effectiveness. So I think from our point of view, the sort of things we've realised from the research is that currently we mostly know how to do these sorts of jobs. In fact, most of what we implement has been developed over the last 30, 40 years of soil conservation. And you might see some of the sort of approaches we're taking in these agricultural landscapes are the same ones that are taken on road jobs, incidentally. So we do know how to do what we do, and we're glad that the monitoring of that work is showing that we are actually competent at what we're doing. We do think that there could be some better, more standardised approaches for measuring cost effectiveness, because we find that we're in a competitive space to be able to deliver these sorts of jobs, and so we're interested in doing it in a cost effective way, and we want to be able to be sure that people are measuring those things in the same way, so we feel like we're talking apples and apples there. One thing that wasn't touched on by Andrew, I think, was that once we do these works, there actually is maintenance involved afterwards. If the work's done at a very high standard, you can be quite sure that that maintenance is going to be relatively cheap. So the Strathalbyn example, which I'll talk about in a little bit of detail in a second, it's had a maintenance cost of about 1% of the capital cost in the first year, and many of the sites then don't need maintenance, and some of the sites, in fact, in the treatment options had needed no maintenance. So we can be sure that we're going to preserve the yield reductions. The other thing that's probably come out of the research is and this is from the different people who have researched gully systems and how much sediment are coming out of these systems, is that it would be great if there was some sort of standardised approach to do that, because different people are doing it in different ways. So that helps us work out budgets for being able to deliver these programs as well. I'm pushing the right button. Has it run out of a battery? No. Okay, just an example, quick one. When we're talking large-scale gullies, this is another example, one we looked at in November of 2017. And just an example, we can get quite good results that mimic what these sort of landforms probably looked like before they became eroded. So it's all been good stories so far, but I think it's worth, at this point, going through a bit of an exercise of looking at where we are at now and where we're going to head with the programs that are supporting this sort of work in the future. That's a picture of the Strathalbyn site. And the first point I wanted to make was that not all gullies are equal, and I think that was addressed in that last talk. So when we look at implementation, this site at Strathalbyn was actually a really good site because logistically it's very efficient. It has some very high yielding gullies in a very tight location. It is a very remote site, so it had difficulties associated with that, but we were actually able to do a lot of remediation in one spot. So once we set up there, we were able to produce a lot of on-ground work very efficiently. So in actual fact, through the various programs that have occurred at Strathalbyn, with the support of the landholders, there's been the Reef Innovation Fund, Greening Australia, also Reef Trust, 2 rounds of Reef Trust, and Great Barrier Reef Foundation has funded some work there. We've actually probably done about 30 hectares of direct interventions there, and that's not in the catchments, that's actual eroding gully scarps. So it's a very large project. Some of the more recent sites we're working on, you don't get that concentration of high yielding gullies. So that means that when we mobilise to those sites, we have to work in many different areas, many smaller clusters to be able to get anywhere near the sorts of sediment reductions that are generally being looked for in these programs. So logistically that's a problem, but also for the owners of those properties, having a civil construction style project going on for multiple years on a property that's a grazing property can create, a bit of tension between what is fundamentally their business is grazing and having these sort of programs. And that's something that when people talk about getting the low-hanging fruit, I think they're talking about getting the ones where you've got willing landholders and also high concentrations of very high-yielding gullies. And as we go into the next 5 or 10 years of this stuff, if it goes on that long, then we're going to slowly get into situations where the cost effectiveness will reduce because it's actually getting harder and harder to get these sort of gullies to remediate. I also want to introduce a concept that's based around this remediation work we've done at Strathalbyn. It's this concept of the Strathalb. So I'm going to define Strathalb. It's essentially, it's a program that runs over 4 years. It produces a net fine sediment reduction at the reef of about 10,000 tonnes per year. It costs about $3.4 million to implement on ground, and that's not project management costs, that's the direct cost, and it probably employed and touched probably about 50 businesses. So if we use that as a unit of measure, then I want to compare what we've done there in 4 years with what we're aiming to do in the future. These programs are big. Okay, that's another site. Just you can see the scale. You can probably see a dozer in there. It looks tiny in that picture. So if we look at the targets that have been set for the Burdekin, the Reef 2050 target for the Burdekin to achieve by 2025 is about 890 kilotonnes. So if we're going to use the measurement of a Strathalb, we're essentially looking at about 83 Strathalbs to produce that target. So, technically it's possible. We can do it. We know we can do it. We've been told that 30% of the sediment is coming from 2% of the gullies, so we know we can target into those areas. But we're talking 83 projects of the size we've just completed in the last 4 years, and that will mean a massive scale up if that's to occur. So on that basis, if we're using 83 strathalps to produce that target, then we also want $282 million. So North Queensland Stadium was 293 million, and the Townsville Ring Road was 230. So, you know, budgets are being thrown around for that, for infrastructure works, and if we really want to get serious about these erosion issues and the sediment production, then you're looking at a program of that size. Back to our friend the elephant. So it raises a few questions for me, and it's certainly been the topic of discussion at various work sites I've been on, when landholders are like, you know, how much of this stuff can you do? These are big programs, they're expensive, they find it difficult sometimes to understand why we're even interested in this stuff. And I guess, you know, the sort of things people are asking, are the targets wrong? Are we really able to achieve that? Is it possible? Is the business case for doing that flawed? Is the delivery model wrong? And what's the way forward, I suppose, is the next question. We spend months of the year out doing this sort of stuff, doing very long hours in the field, you know, 10 to 16 day swings to achieve this work. I don't know if anyone has ever seen Minority Report. It's a crap movie. But I like it because what they're doing in that is they're looking at future criminals. And so it's predicting the future, what's going to happen. And I particularly like the way Tom Cruise just totally organises the whole thing. And I think that's sort of what we're going to need for the gully erosion sphere. So I want to hone in on the Triple B. So that's the next one that's going to, the next focus area, I suppose. It's been identified as a very high sediment production area. I should say too, I'm not obsessed with sediment or gullies. It's just one thing that I do. But when I look at the Triple B, so we've heard that 30% of the load is coming from just 2% of the MAP gullies there, so we can target that area to get a big reduction. The target for the Triple B is 332,000 tonnes, you know, in basically the next 4 years or so. So let's go back to strathalbs again. We're actually dealing with 33 strathalbs for the Triple B, and that's an investment of $112 million to achieve that, which is a lot more than what's currently on the table. If we also look at the workforce to achieve that, that's about 1,650 people to put that on ground. We only work for 5 or 6 months of the year because of the dry and the wet seasons. So if you think sort of carefully about that sort of equation, there is a big opportunity there. It is possible to do, but maybe the delivery model needs to change. And as a consultant, it seems sort of ridiculous, but I think really people like myself should probably get out of the picture, and it should probably be pulled into some sort of soil conservation service at that scale. So the benefits of that would be that you'll get a dedicated workforce. You'll also get people who can collaborate over a longer period with researchers like yourselves, and other people can get a reputation for doing the right thing, and we'll also be able to hopefully keep knowledge inside an organisation to be able to expand that, use the stuff coming out of research to try to improve their delivery effectiveness and you know, make a lot of local jobs essentially. So that's one option. There's probably another heap. Hopefully if someone else has got a better idea, they can, you know, put it up in the questions or the answer section of the forum. I think I might leave it there. All right, thank you.